Okay, so I just want to make sure that you're writing things the way that needs to be written. If we are asked for the maximum value of f, I could ask for the absolute value of maximum of f. The maximum value of f would be 8. And if this y-axis were cost dollars or whatever units, then you will say, I don't know, $8. And that will be the largest value, the largest always y value. And if the question said where f has an absolute maximum value, where, so then the question is asking for the x value at which that occurs. So where at x equals 2. Okay. The same with minimum. If you're asked for minimum, then you're asked for the lowest y value of that. Y values always. So in this case, we can talk about an absolute minimum value because we have a closed interval. And not only that, but we also see the entire f, and we know the behavior of that. So the absolute minimum would be 1, and if that was units instead of dollars, would be I don't know, velocity, then it could be miles per hour. Okay, for an example. And again, if they ask you for where does this happen, then I've been asked about the x value at which this happens, and that will be x equals 6, because this lowest point happens when x is 6. Now, when we talk about local minimum and maximum, for example, let's look at this cubic function. You know that it continues forever and ever in these directions, and therefore there is no absolute extrema. And when I say that, remember that the word extrema refers to maximum and minimum, all together in one word. So there is no absolute extrema. However, there is some local maximum right here, because for these other points, this is the highest one, and in here this is a local maximum, and in here I have a local minimum, and it just happens to be the one for which this is the lowest point for all the points around x equals 1. So this is the one that has the lowest y value, but it's not the lowest of them all, because points over here have lower y's than that one does. So therefore it's only local minimum, and it's not an absolute minimum. So again, where I forgot the h, where does f have local extrema? So you have to be specific. If they ask you for local extrema, then you have to say local maximum, and then you have to say local minimum, and then you have to say how much those are. The local maximum here is -2, and the local minimum is -4. At x equals, the local maximum occurs at x equals -1, and the local minimum occurs at x equals 1. Okay, just to have that clear. Now, we may not have even numbers, and we still can talk about maximum and minimum values. For example, I notice if this was a closed interval function that starts here and I know ends there, then I know that I have an absolute maximum at x equals a. And if they ask me how much that is, well, I would say it is f of a, whatever that is. I mean, I don't even have an axis in here. So whatever f of a is, that's my absolute maximum. And the absolute minimum here occurs at b, x equals b. And then how much it is, then that will be f of b, whatever that y value at b is. In here, whatever that value of f of a is. Now let's look at one of the examples from the book. I'm looking at example 8, and it's talking about the function y equals x cubed minus 3x squared plus 1 between negative 1/2 and 4. Now remember that this is less than or equal to. This is the equivalent of saying between negative 1/2 to 4. So it is a closed interval, and it is a continuous function because all polynomials are continuous functions. Therefore, I can apply my theorem. So the first thing it says on the step, find values of f at the critical numbers of f in AB. So let's find the critical values. Critical values occur whenever f prime is 0 or f prime does not exist. So we have to check for both conditions. Now, I can tell you right now, this is a polynomial, so the derivative always exists. So we are not going to have this case in this situation. But depends on the function. If we are talking about a rational function, probably we're going to have a few of those cases in which the derivative does not exist. So let's look. What it is that we need to find is the absolute values, the absolute maximum and minimum. That's our task. Now, if we don't have a calculator, we're gonna put on our algebraic glasses, and we're gonna be able to see what it is that we cannot see without graphing. So the first thing, I need to find my derivative. So I find the derivative, I use power rule, 3x squared minus 6x, derivative of 1 is 0, and that will be it. Now I want to know for what x is, f prime of x is 0. So I'm going to equal that to 0. Now I can see I can factor out greatest common factor. And, sorry, this is 3 times x minus 2. So x is 0. Or x minus 2 is 0, which gives me x equals 2. So I have some critical values at x equals 0 and x equals 2. Now for those critical values, I must find how much f is at those 2 points. So f of 0, I'm going to replace on the original, 0 cubed minus 3 times 0 squared plus 1, and that gives me 1. And f of 2 would be 2 cubed minus 3 times 2 squared plus 1. Now this is 8 minus 12 plus 1, negative 3. Now the other thing that I have to do is, in step 2, it says, that's the first thing, right? Critical value is the first thing. The second thing that I have to do is, actually I have to find how much is f. The second thing, find how much is f at the endpoints. So I'm going to find how much is f of negative 1/2, and then I'm going to find out how much is f of 4. Now f of negative 1/2 would say negative 1/2 cubed minus 3 negative 1/2 squared plus 1, and that is actually 1/8. And then f of 4 cubed minus 3 times 4 squared plus 1, and that gives me 17. Now let's see. Now we're just gonna compare and see which one is the absolute value and which one is the minimum. So I have negative 1/2, I have the other one is 0, the other one is 2, and the other one is 4. And f of this is 1/8. F of 0 give me 1. F of 2 give me negative 3, and f of 4 give me 17. And I just want to know which one is the highest one and which one is the lowest one. So in here, this is the highest, so that will be my absolute maximum. And out of these numbers, which one is the lowest one? This one. This one is my absolute minimum. One thing that I want you to appreciate from this in here, these values in between may or may not be actually local minimums or maximums. So let's sketch a graph just for fun to see what it is that we have. So at negative 1, 1, 2, 3, 4. Okay. So at negative 1/2, which is over here, I have 1/8. So that's a very small value of y. And then I have at 0 I have 1, and then at 2 I have -3. This is just a sketch. Oops. If you're sketching, at least make sure that if it looks like a local maximum, then it looks like it, and don't go any higher than that point. That's obviously a mistake there. And then at 4 is 17, so it goes up. Okay, 17. So my function looks like that, and this one is the absolute maximum, and this one is the absolute minimum. And one thing that I want you to observe is that although this is not an absolute anything, it happens to be a local maximum. Okay, and in this point, for example, this endpoint happens to be nothing. I mean, this is not the highest of them all or the lowest of them all. You may argue that it's the lowest around here, but if you were, since you don't have any other x's on the left, you can really judge that that's the lowest around -1/2, because you don't have around -1/2, you only have on one side of -1/2. So this is nothing. You will have to see around those values, both sides, left and right, to be able to judge whether if it's a local maximum or minimum or something. Also notice how the absolute minimum happened to happen at a critical value, whereas this absolute maximum happened at one endpoint. So that could be the other case, that it happens at one of the endpoints. So that's why it's always, this second step right here is always something that you have to do whenever we have a closed interval. And then also, it depends on the function. It depends on where you are focusing. If we have to have the same problem, the same function, but instead of -1/2 4, I have it on the 3 to 4 domain, meaning I'm only looking at this portion of the graph and nothing else, then we have a different set of values. The absolute maximum will be the same, but the minimum will be this point rather than this point right here, because I'm not including it anymore. So it does not only depend on the function, but also depends on the domain that you're looking at. Now in example 9, I'm going to show you how to do this with the calculator. And now I put in my function and I graph. And the first thing that you must remember is whenever you're graphing any trigonometric function, please check the mode of the calculator. It must be on radian instead of degree. I noticed that there was something fishy when I graph a function with a trigonometric function in it, and it didn't look wavy. So that raised a concern. I went to mode and I changed to radians. So now I'm looking at this function. The window, since they are giving me an interval between 0 to 2 pi, then definitely I want to include that on my window. So in here you can actually put, well, I put the 0 already, but you can put 2 pi and the calculator will know that you're talking about that number. So now I'm looking at the right window, I'm looking at the correct graph, and I'm going to estimate using this calculator how to do this using the commands under calc. So I'm gonna go to calc, and then we have used the zeros before, and we're gonna use either maximum or minimum depending on what it is that you want to find. So let's start with maximum, and I scroll down. Now the calculator is asking me, first of all, what function. So you see the function is x minus 2 sine of x. Then the calculator wants to know what is the left side of this maximum. So if I know the maximum is right here, I want to put this blinking dot anywhere to the left of that dot. Now over there is fine. Now it says right bound. Then the calculator wants to know what is the right of this maximum value that you are thinking. So I must take this blinking dot, not where I think is the maximum, but to the right side of it. Now if I'm thinking this is the maximum, I'm on the right of it. So I say the calculator yes. Your guess, I don't know. And then the calculator is going to position itself on the maximum point, and it's going to give you the x and the y coordinate of it. So where does this occur, this maximum? At x equals 5.23598. And how much is it, or what is the maximum? The maximum is 6.968. Okay, 4 decimal points to be safe, and that would be the estimate of it. Now if I want to find the minimum, then I'm gonna go to calc and I'm gonna pick 3, and now the calculator wants to be on the left side of the minimum. Notice how the minimum occurs over here, so I want to be on the left side of it. So I'm gonna go over here. It takes forever. Alright, now I'm on the left. I press enter, and now the calculator wants to be on the right of this point. Okay, and then your guess, leave it alone and press enter again. And now it's going to position itself on the minimum, and it's going to give you the approximate x and y values. Now, what is the minimum? Negative 0.6848533. Where does it occur at? At x equals 1.047. Okay, so that's how I found out the calculator. Awesome. However, we're gonna be able to do it with our calculus classes. Yay! Okay, so since we're talking about a closed interval and this is a continuous function, continuous, yes, because this is continuous, the difference is continuous, and this is closed interval, then I can follow those 3 steps that I did before. So the first thing is finding my critical values. So again, I want to know where f prime of x is 0, or I want to know where f prime of x is undefined or does not exist. So let's find f prime of x first. When I take the derivative of x is 1, and derivative of minus 2 sine of x is minus 2, sine of x is cosine of x. This is not chain rule because there is no function. This is a constant multiplied by sine, so the derivative of sine is cosine, and the constant stays multiplying that. So that's no biggie. It's no chain, please. Don't think of it too much. So now I want to make this equal to 0. Now I notice that this is a continuous function, and not only that, but there is no x's for which this is not defined. So this option, you're not going to see it. If I had a function that says 1 over x minus 3, then I know that it's not going to be defined for x equals 3. But we don't have that case, so this is not seen in this example. But it may happen, so be aware. Okay, so I'm going to find those x's here. I'm going to solve for x, so 1 equals 2 cosine of x, and then 1/2 equals cosine of x. And you know that there is infinitely many x's for which the cosine is 1/2. However, I'm only working on this closed interval, so therefore I just need to find it. Now the answer here, x is the arc cosine of 1/2, and now the arc cosine of 1/2, you ask yourself for which x the cosine is 1/2. So the cosine is 1/2 for let's see, the sine of pi over 6 is 1/2, so the cosine of pi over 6 is root 3 over 2, so it's not pi over 6, it's pi over 3. Now remember the unit circle. if I want the cosine to be 1/2, remember that the cosine is this distance on the unit circle. So if this is my radians right here, the other one is going to happen over here. So it's not only pi over 3 whose cosine is 1/2, it's also pi over 3, 2 pi minus pi over 3. So that would be 2 pi minus pi over 3, that would be 5 pi over 3. So for those two values, the cosine is 0. So now the other thing that I have to do is find f at endpoints. Now with f at endpoints, I'm gonna do f of 0 and I'm gonna do f of 2 pi. Notice that I do f and not f prime, please. F of 0, that will be 0 minus 2 sine of 0, and sine of 0 is 0, and this is 0. And f of 2 pi would be 2 pi minus 2 sine of 2 pi. Sine of 2 pi is 0, so this is 2 pi. I forgot to find my f at my critical values. So f of my critical values, f of pi over 3 and f of 5 pi over 3. Pi over 3 minus 2 sine of pi over 3 and 5 pi over 3 minus 2 sine of 5 pi over 3. And that will be pi over 3. Sine of pi over 3 is rad 3 over 2. So this is pi over 3 minus 2. Minus rad 3, because these two cancel out. And then in here I have 5 pi over 3. Sine of 5 pi over 3 is the same as sine of pi over 3 with a negative sign. So it's negative rad 3 over 2. And that will be 5 pi over 3 plus rad 3. Okay, so let me put my results on a table because that's the way that it helps me visualize this. So the endpoints are 0 and 2 pi, and the other two values that I have in between are pi over 3 and 5 pi over 3. I just want to put them in order because if I were to graph this, at least I know that they are in order. So f of 0 was 0, f of 2 pi was 2 pi, and f of pi over 3 is pi over 3 minus rad 3, and the other one was 5 pi over 3 plus rad 3. Now I really have no way of knowing. I do, but I'm just gonna put this on the calculator because I want to know which one is bigger. So pi over 3 minus rad 3 is that much, and then 5 pi over 3 plus rad 3 is that much, and then 2 pi is that much. So I notice that this value is bigger, and then the lowest one is this one that is a negative number. So the absolute maximum is 5 pi over 3 plus rad 3, and it occurs at x equals 5 pi over 3, and the absolute minimum, there's no I, is pi over 3 minus rad 3, and it happens at x equals pi over 3. Now the minimum and the maximum didn't occur at either of endpoints, which is absolutely fine.